All right, so maybe it'd be a good idea to review some of the ideas that we were exploring in the last lecture before we move on to other topics, since they were fairly challenging and complicated concepts. All of this had to do with the three big questions about living organisms. What is the definition of a living organism? How can you define the distinction between living organisms and non-living beings? Right. Then there was a question of the compositional unity of a living organism. What unites the parts of the organism into a single unit, a single cohesive unit? And the third question had to do with the definition of life itself. So the big thing that has to be recognized, I wanted to say, was that a living organism belongs to a natural kind. Natural kinds are kinds that figure in natural laws. So in that way, they're distinct from artificial kinds. So an example of an artificial kind or artifact kind would be table or ship. And we've seen the issues of identity with those kinds of things that cast doubt on the reality of things of that sort. Primarily in the minds of many philosophers, because things of those sorts wind up getting duplicated. So it seems, for example, in the problem of increase that we talked about, if we say that your house got bigger by adding a room on, then we wind up having to say that there's both the matter that makes up the house and the house, because the house can get bigger even though the matter that made it up didn't get bigger. Right? If the house was made of A on Monday, and then on Tuesday you've added a room on, then the house on Monday, the matter of the house on Monday was A, and A doesn't get any bigger, but the house gets bigger on Tuesday because it now consists of A plus B. So it seems like you had two things in the same place on Monday. You had A and the house, and the house has properties that differ from A, like being able to get bigger. It has the property of being constituted by AB on Tuesday. But A, the thing that made up the house on Monday, didn't get any bigger. It's in fact a proper part of the house on Tuesday, and therefore diverse from the house. So we wind up with two things in the same place at once, which is definitely messy. In the case of organisms, though, you don't really seem to see that. When an organism grows larger, which it does, right? As you grow from a baby into adolescence and adulthood, you get larger. There doesn't seem to be anything corresponding to that. The main difference being that a living organism is not made of a single piece of matter. It's a combination of matter and fluids and gases. So there isn't any object that you can call the matter of the organism on Monday, which then becomes bigger on Tuesday. It's just the organism, which is ever-changing object. Yeah.
So if we have a house,
Yeah.
A,
All right, so here's our house, a primitive house. There. Yeah,
And then-
but A symbolizes the materials of the house, like the wooden frame and so on.
right, and then we add an addition to the house, addition B.
Yeah, that's our B. So this is on Tuesday. And Monday, you just have A. So the house enlarges from Monday to Tuesday.
Wouldn't we just say that it became a different house? Just
Yeah, we could say that. We could say,
It's house AB, not house A with
Yeah.
addition B.
yeah, we can say that.
Okay.
But then we're mereological essentialists,
Okay.
and we say houses are very short, are short-lived.
Okay. Oh, like if it loses a gutter pipe, it would also be a
Yeah.
different house? Okay, yeah.
Yeah, or a nail or anything. Yeah.
Okay.
Or new wallpaper, anything.
Yeah.
Yeah. And that seems extreme.
Yeah.
It doesn't seem to be true to our concept of houses.
Couldn't it be argued that,
So you might argue that houses are just a concept, which makes them not physical objects anymore. But that's not true to the concept of a house either, because we think of a house not as a concept, but as a material object. So it doesn't seem to be an easy escape from the dilemma. Seems like you have to make a difficult choice, either to say that houses don't last as long as we think they do, right? Or that they don't exist at all, or that they're actually mind-dependent entities, right? Or that you can have two physical objects in the very same place at once somehow. None of those seems particularly appetizing, but you have to pick one.
yeah.
I guess I would favor the idea that houses are eliminable in favor of pieces of matter. And the reason I would say that is because the concept of a house, the notion of a house that we actually seem to have seems to be inconsistent. Inconsistent in both ascribing materiality to them and at the same time treating them as sort of conceptually based things, which have purposes and functions, which nothing in nature that constitutes them has. So the house is for providing shelter, but the wood that makes up the house isn't for that, right? It's for making the tree strong or something like that. But it's been long removed from the tree since it went through the lumber factory, so it doesn't really have any purpose or function to it anymore. Yet the house does. So it's hard to see how the house even comes into being except through our intentionality. Once you say that, it seems like it's not a physical object anymore. And so it seems to be a kind of hodgepodge entity that are saying it doesn't really exist at all. Than that it's the prima facie credibility that we have in believing in houses, because they are a part of our folk scheme of thinking about the world, perhaps arguably is defeated by these internal inconsistencies within the notion.
Could you repeat that part about prima facie credibility?
Yeah, so remember we said at the beginning of the year that if you observe something and you believe in it as a part of your basic everyday conceptual common sense scheme, that you have a right to believe in that until it's defeated through like a contradiction or something like that, right? And arguably you do get a contradiction in the case of artifacts, things that are not natural but exist through human intentionality.
How are we using intentionality?
How am I using intentionality? Well, we intend it or believe it to have a purpose, like shelter in the case of the house. And a ship is for
buoyancy or something.
conveyance on the water.
Transportation in the water.
Yeah, transportation on the water. Yeah, a broom is for sweeping.
Right.
Hume had the example. This the thing called Hume's broom.
No way.
Yeah,
That's awesome.
Never.
yeah. Hume says, well, if you replace the handle and then you replace
Yeah, like Grandpa's axe.
the whiskey part on the bottom,
Yeah.
you still have your same broom as you started out, but it's completely different. So,
Yeah.
it says these brooms are just conventional objects. They exist not by nature, but by convention, human convention.
So like,
Only.
No, you can go ahead.
was any form of technology that's man-made would fall into this category?
Yeah,
Okay.
unless it has a nature of its own.
Like the sun?
Yeah, I mean, so if you were to synthesize a life form, like from pure chemicals, and it lived and so forth, that would be done through technology, right?
Yeah.
Yeah, but it would have its own nature too, because it would be alive, right?
Like a domesticated animal?
No.
Well, any kind of living thing, like a bacterium or any kind of, if you could. No one's ever done that, of course,
As
but
long as you make it. I think.
well, here's a simpler example. Take a synthetic fiber,
Okay.
like rayon, right?
Okay.
This rayon sort of like artificial silk, right? Nevertheless, rayon is a compound and has its own chemical properties. It doesn't seem to occur in nature, like you don't find it anywhere, but naturally it didn't exist anywhere until it was chemically synthesized by people, as far as we know. So it's man-made, it's synthetic, it's artificial. Yet at the same time, it's just as much a real chemical compound as any other chemical
Even
compound.
basic elements that we only know have existed through us synthesizing them.
Yeah.
Yeah.
Yeah, so a synthetic artificial thing can have its own nature,
Yes.
but it doesn't have to. A thing like a broom doesn't. Why? Because it's wholly at the intentional level. I mean, it doesn't have any. There are no natural laws tying its sweeping functions to its molecular composition or to its physical nature. But for something like rayon, there is, right? It is the chemical substance that it is. Therefore, there are natural laws about rayon. That rayon will stretch like this, and there aren't any natural laws about brooms. Brooms could be made of a wide, different diversity of chemical elements. You could make them out of aluminum, you could make them out of wood, you could make them out of straw, you could make them out of metal, right? They're all brooms. So broom doesn't correspond to any natural structural kind in terms of molecular composition. But rayon does, right? And so do carbon-based living things, right? So if you created a carbon-based living thing in a test tube out of raw materials, it would then be just as much a living thing as we are, even though it was artificially created.
What about AI?
Oh my goodness.
Wouldn't that be the same thing?
AI?
Hard AI.
Like
Meaning-
artificial intelligence.
Like,
Yeah.
Yeah. Like instead of like just something that.
It would.
Okay.
Though it's not. If we're talking about actual examples or hypothetical possible examples, talking about like building a conscious robot.
Yes.
Yeah. Well, that doesn't actually exist, but if it is possible, right?
Right.
Then those things would have a nature of their own too. Yeah. Even though they were synthetically created, they would be they'd have mental life and would be conscious and all the stuff we are. So
So it wouldn't even necessarily have to be organic.
No.
AI.
no, it wouldn't have to be. It might be made of silicon, which is a close relative of carbon or whatever. So it'd be sort of quasi-organic, since they're right next to each other on the periodic chart.
So for one of our
Apparently, a biologist told me that at very high temperatures, actually silicon forms macromolecules like carbon does at what we consider to be normal temperatures. So you maybe could have chemical silicon life that lived at like really high temperatures, like thousands of degrees or whatever. At room temperature, it doesn't form all of these complex chemical forms. So silicon's not going to be a basis for life at these kinds of temperatures, but maybe at very high temperatures it would behave like carbon, and you could get silicon-based life. So who knows, right? We can't assume anything a priori about that. Yeah. So what I was saying with living things, though, you don't seem to have this kind of like addition of blocks to each other or anything. I mean, you don't get that story because you, the living organism, right now, your body does not constitute a single object like A. It's made up of some bones and some blood and some this and some. So you don't get like a single object to add on to.
Unless it's plants, you could graft a wild branch into a natural plant, and therefore you'd have an addition, right?
Yeah, the trouble is that the plant, the thing that you're grafting on and the thing that gets grafted onto are not solid objects.
Oh, okay.
They're full of
It's
liquids and
complex.
so they don't correspond to these like pieces of matter.
Can an organism be like a part of another organism?
I don't think so.
Yeah, see, it's like a puzzle.
It seems like it gives up its autonomy when it joins up and
So-
becomes like part of a bigger system.
Right. We have like a gut biome.
Yeah, the gut biome.
Like a candidate for an organism that might be a part of another organism. Because we could like take a cell out and put it in a petri dish, and then it would be its own
Well,
organism.
yeah, but there's also the concept of symbionts.
Right.
So they seem to
okay,
be,
So it would be a part, but it would be two organisms in a mutual. Okay.
I would say it's not a part.
Right. Okay.
I would say that the bacterium has its parts, which are its nucleus and its mitochondrial
Okay.
bodies and so on and so forth. Mitochondria themselves may have started out as independent organisms, but they signed up to belong to right
Larger.
the larger entity. They've lost their autonomy now, and they seem to be parts. What's the criterion for when a living entity is part of a bigger system versus when it's in a pathogen or a symbiont, right?
All right.
Well, I talked about the master part concept last time. I think that provides the criterion. So it really has to do with how much control the bigger organism has over the other organism that's inside of it.
Right.
So if it controls all of its activities to serve the greater whole, then it's a part. But if it doesn't, then it's a separate organism.
Okay.
So we have a way of,
So autonomy is the key to
yeah,
art.
yeah. And autonomy is generally what distinguishes substances from other things.
Complex.
Whether a thing is an entity in its own right, standing on its own, or whether it's just a part of a greater whole, is the question. Yeah. So yeah. So I laid out some criteria for for an entity being a carbon-based living thing. And they mainly had to do with certain kinds of basic life functions that organic living things possess. Can anyone tell me what any of those were?
I got it. So the first one is that it's carbon-based,
Right.
oxygen, carbon, and nitrogen. And then
Mhm.
Or answer the questions and answers.
No, I was just saying, what are some of these basic features of the carbon-based living organism? So, yeah, one of them was that it's made of carbon-based macromolecules, very large carbon-based macromolecules that have a high capacity for biochemical reactions with other organic molecules. So they're very
You
active.
say symbiotic?
No, it's just the reactions are very selective. Yeah. Also, it's surrounded by a membrane through which things can pass through the membrane. Molecules can pass through that membrane.
Absorb and excrete.
Yeah, it can absorb and excrete,
Metabolize.
metabolism, biosynthesis, and all of these functions are cyclically related. That's very important. So there's a cycle in a living thing. Absorption and excretion cause metabolism, which then causes synthesis, and the synthesis contributes to the levels of absorption, excretion, and metabolism. So it goes around in a circular fashion. That's an important aspect of the carbon-based living organism. There's also the reproductive element through the phenomenon of the self-copying molecule. Is the DNA. So living things belong to a very special natural kind. The natural kind can have instances which reproduce through one of their proper parts copying itself. So a proper part of any organism is DNA, and in some cases that DNA can copy itself, and by that means the organism reproduces. It's not true of all organisms that they can reproduce. Some are sterile, but it's characteristic of the natural kind that members of that kind reproduce, even though there are sterile members of the kind. It wouldn't be the kind that it is unless some members of the kind reproduced, right? No, it wouldn't be that kind. Then. Right, the kind that it is, the kind that involves a self-replicating organic macromolecule. The only examples we know of those are RNA and DNA. There might be others, though. Chemistry doesn't have the ability to absolutely predict the properties of giant molecules. We sort of have to find them in order to know that they're possible. DNA is the largest known molecule. But maybe there could be even bigger ones made of other kinds of carbon-based that could serve as nuclear molecules for carbon-based life forms of different sorts than we're familiar with here on Earth. But we'll just go with the ones we know about. Right. And finally, an organism is possibly stands all on its own. It's not a part of a bigger system of that sort itself. It is the whole system. Right, so that's what an organism was. And then I said that I argued that every organism has a master part.
That's what their identity was.
Yeah, their identity is determined by the identity of their master part. So, like a paramecium has a nucleus, which determines the identity of that organism. So if you take its nucleus out and put it into a different paramecium, then that becomes the paramecium you had before. Right. if we could take your central nervous system out and put it into somebody else's body, then you would take up residence in that new body. That is, you, the organism, would take up residence in there. This is not a claim about personal identity, though, unless persons equal bodies, which they may, but that's a further thesis. It's talking about organismic identity here. So, of course, you can't do that. So, to find actual examples of switching identities through master parts, you have to go to fairly simple organisms that have a nucleus as their master part.
There are bacteria that have organelles that allow them to exchange gene sequences.
Yeah.
So seems like it might be a naturally occurring process of exchanging master parts.
Well, they're exchanging just...
Or parts of their master part.
Yeah, that's not the same thing. It's just parts of it. There may actually be duplicates of parts of them. I mean, I assume that in this process of genetic exchange, right, that the bacterium in question has a strand of DNA which is able to replicate parts of that strand and then send it over to some other bacteria that has, conjugated with it or something like that, right? They would be exchanging some genetic material, just like we do, to produce a fetus, right? So it's a kind of sexual reproduction, perhaps, or at least exchange of genetic material, which then alters the genome of the receiver, which then replicates through binary fission or something, but with a different genome than it had before.
Right.
Yeah. So, yeah. So the idea is that every living organism has this master part, and the master part regulates and controls its biological functions. Part.
I actually had it written as master part in my notes.
Has a master part.
We're constantly running the credit.
Yeah, so the part in question is the organizer, orchestrator of the symphony of living functions, life functions that keep the organism going. So it's going to keep, for example, in the case of a human, it'll make sure that your heart rate is neither too slow nor too fast, that your temperature is neither too low nor too high.
Homeostasis.
Yeah, it'll keep everything within a range that's required to keep the organism alive. Yeah.
Did we say that that's transferable?
Transferable?
Yeah, between organisms. Is that what we said?
No,
Not with the master part. Okay.
no, we didn't say that.
You think a human brain and put another brain body would it still exist and function?
If you could do that, yeah.
I think it would though.
I don't think you can, though. Like remove the whole central nervous system from...
Yeah, I feel like the body would just reject it.
It would. Right?
Does that say something about
I don't think you can remove it without damaging it irreparably.
Well, then it would be something different.
You can't take it out without killing it, basically what it is. At least with current technology. It's too integrated in. So that's in the realm of pure science fiction, whatever. There doesn't seem to be any evidence that you could actually do it. But it can be done with really simple life form. You can take the nucleus out of a single-celled organism and plop it into another. In some cases, you can exchange the nuclei. And it seems plausible to say that then you switch the identities of Two cells, because what is the identity of that single-celled organism really consist in? It seems like the core thing is what carries the identity. The rest is just sort of peripheral stuff, liquids, the surrounding materials are much more contingent to the organism's identity than the core. So you can say that an organism X is identical with an organism Y if and only if X's master part is the same as Y's master part. So if X and Y have different master parts, like you come across this weird two-headed turtle, and you have to decide whether it's one turtle that has two heads or two different turtles that are stuck together. You can decide this by investigating the turtle and discovering that it has two central nervous systems. It has a brain and a spinal column that goes up to this head and a different one that goes up to the other head. There are actually two master parts inside the turtle. So therefore, it's two different turtles that have grown together. On the other hand, you could find a single turtle with like two hearts, and then you would just say that it has an extra heart because it only has one master part, only one central nervous system. Turtle has the one central nervous system. It grew some extra hearts due to a mutation or an accident. Turned it into a bit of a monster that has two hearts, but
What about Siamese twins?
yeah, that would be the same thing. Yeah, so Siamese twins are two separate organisms that happen to be fused together.
Is this solely biological?
Yeah.
Could we argue that it's not the fact that that there's two central nervous systems, but two souls?
Well, maybe they're different persons because they have two souls, but that would require a separation between the person and the organism. But if you don't make that separation, then you just have two organisms, and you have two because you have two different central nervous systems.
Is that just a mnemonic possession?
What do you mean?
Like when you have two souls within one body, that's just like being possessed. Because it's like inconceivable to have two souls within one body.
Well, I'm saying for like the case of like Siamese twins.
Oh, okay.
Yeah.
Yeah, so I'd say there's actually two bodies there.
Oh, yeah. Oh, yeah.
I mean, they're fused. Yeah, they're fused.
Could've been like they were-
They're two living things, two living bodies that are attached.
For whatever reason.
Yeah.
Okay, yeah.
It's not one organism that has like two brains, two heads.
Right.
I'm saying one organism could have two hearts, but it can't have like two central nervous systems. I suppose you could have one organism that, maybe had two heads and one central nervous system, where like one of the heads is a puny little like that.
Yeah.
So that, but then you wouldn't have two central. The brain is not the master part. It's the whole central nerve. Yeah, the brain, spinal cord. It's the whole central nervous system. That's the individuator.
What about one spinal column?
Mhm.
It's like 8 different brains. Is it one creature?
Yeah. I'd say it's one creature. There might be more than one person in there. But then you'd get an argument for dualism or something, if you could have that. But it doesn't exist, however.
Right. Yeah.
Right? We don't have cases of that.
Yeah.
So there's no reason to believe it's actually physically realizable in our world. Thought experiments like that are interesting, but it's hard to draw firm conclusions from them unless you know they're really possible.
So if we had two identical clones, exactly
Yeah.
same central nervous system, so.
What do you mean now? You mean exactly similar to central nervous?
Exactly similar.
Yeah. But they're two separate sheep.
Two separate engines, yeah, sure, sheep.
Yeah.
We call one Kevin, and we also call the other one Kevin. And one of the sheep were to get eaten. Then, where am I going with this?
I don't know.
I don't know anymore either. Never mind, I lost my train of thought.
Yeah. Right. So that's the master part idea. And then the question is how precisely can you define the master part? So I argue that it has to have three elements. It has to be a vital organ, like a heart or a kidney. So a vital organ is an organ that has a biological function such that the organism cannot live for long unless something performs that function. So I know I did, but I didn't write it on the board. Let me, so the master part is vital, necessary, and controlling.
Or regulatory?
Yeah. Which do you like better, regulatory?
Oh. Yeah.
I like the word regulatory because it like kind of implies the homeostasis aspect, but like the part controlling because it shows like an autonomy to the individual being.
Yeah. I don't know. Either one. Okay, so it's those three. So a vital part has a function such that the organism cannot live for long unless something performs that function. It can't live for long. It doesn't mean it immediately dies, though. Like, you might be able to live without your stomach for a while, whatever, right? It's still a vital organ, because you can't live for long. Relative to the normal lifespan of your species. It'd be very short, like a few hours, right? Relative to a 70-year, 80-year, 90-year lifespan. Cannot live for long unless something performs a function. So food could be provided to you through tubes, which is pre-digested already, right? And then that would be performing the function at the stomach. Then you could live without the stomach, provided something else does it. Yeah, artificial life support or something. Okay, then a necessary part is a part such that the organism being alive at all at a given time entails that the organism has that part. That's a necessary part. So like your brain's a necessary part.
At all times.
Without that part at a given time, it would be impossible for your body to be alive without the brain or the whole central nervous system. So that's a necessary part. A necessary part. And the distinction between the two has to do with time lags. So if your head's chopped off, you immediately die, whereas if your stomach is removed, you don't immediately die necessarily. So a necessary part is such that the organism's being alive at a time requires that it is part of the organism at that time. So a necessary part is such that the organism's being alive at a time entails that the organism has that part at that time. Like your brain. It's a necessary part. So there's this big asymmetry between the brain versus the stomach or the heart or the liver for the organism.
Isn't that because of what they control?
Yeah, exactly.
Okay.
The central nervous system controls the whole organization of the organism. So
Right.
if you disrupt that, the organism can't be alive anymore. But any of the others don't have a central role. They have an important role. You can't live for long without your heart working. Or whatever,
They're
right?
almost parasitic to the central, right?
Yeah,
So
they serve it.
Sure. Yeah.
They subserve.
So you can have other parts of your body that are vital, necessary, and controlling, but what makes the thing the master part is it's...
No, you can't. What makes it the master part is that it's vital, necessary, and controlling. There is no other part like that.
Oh. Okay.
So take some like big part of you, like all of you except the tip of your nose. Right?
Yeah.
Like everything back from the very tip, that big part. So that's vital and necessary, but it's not controlling. Right?
Yes. Well, what
It
about...
doesn't control everything. What controls everything is the central nervous system, not like all this other stuff, right?
Yeah, the liver can't control the central nervous system.
Yeah. It's the other way around.
But what about portions of the central nervous system that could break down?
Yeah.
So there's parts of the central nervous system
Yeah,
that we can just take
Yeah,
away.
yeah, and they could. Yeah, so other parts might be vital and necessary, but not controlling. That's what I'm saying. There can be parts that are vital and necessary, other than the master part, that are not controlling. There can be parts that are vital and non-controlling.
Yeah, the nerves in your foot aren't vital to the system. You can do without a foot.
Yeah,
Right. Right. But I can also... actually, no, I can't. I was going to say I could do without a good portion of my spine, but not the vital part.
Yeah.
Or the necessary part. Yeah.
yeah,
Okay.
yeah,
That makes sense. Thank you.
yeah. Right, and then the third thing is it's controlling, and yeah, I'm not going to write that out because to define that formally is like extremely like technical and doesn't really add anything to the basic idea that for each function, biological function of your parts, bodily parts and organs, the master part causes that function to remain within a maximum and minimum range in the sweet spot, or a relatively sweet spot. right, so that your heart doesn't go too fast or too slow, and so on. So it regulates bodily functions. It may do so directly or indirectly. So, for example, the nervous system might regulate the secretion of hormones by the endocrine system, which regulate growth of the body, for example. So the controller might control something, which then in turn controls something else. And so on. So you might have a hierarchy of regulation. Right, but the central nervous system is the core of the regulation. And for simpler organisms, you have different kinds of master parts. So, like it might just be the nucleus or a system of nuclei in the case of multinucleated cells, which coordinate with each other. So, for example, in a plasmodial slime mold, when the thing's going to reproduce, all of the nuclei divide simultaneously. It has thousands of nuclei, yet they all undergo fission at the same time. It's coordinated because clearly they're in biochemical communication with each other. It's a biochemical network. As the nuclei control the functions of the slime mold. Has lots of nuclei, so it's not like the paramecium, which just has that one big one in the middle. So, yeah, so each living thing has its own way of controlling its functions. What controls the master part, though, you may ask? Clearly, it must control itself, since there's nothing else to control it. So it's going to be self-controlling. So you may ask, why can't the organism itself just be self-controlled? Why do we need the master part? Well, it seems like we need the master part because life begins with DNA, which is a controlling molecule. And it's just an empirical fact that living things have master parts. I'm not claiming it's a necessary truth or that all possible living things would have them, because there can be self-controlling systems since the master part itself is self-controlling. So there could be life forms that are self-controlling and don't have master parts, but it seems to me the empirical evidence suggests that all carbon-based organisms that we know of have a central controlling system of some sort, even if it's fairly decentralized, such as what we find in plants, where the master part is essentially the whole plant aside from its sap, since it doesn't have a nervous system or any kind of organ that controls everything in the plant.
Could we say in nature there's a natural hierarchy based on creation?
Maybe we could say that if we could
If
we could define precisely what that means.
If there's a universal law to cover that.
Yeah, that's the thing. The organization of living things falls under, I think, natural laws, which have to do with not only biological principles but biochemical laws. So I think part of what singles out living organisms as a special category is that they have master parts. At least the carbon-based ones, right, have master parts. However, there are other systems in nature which are orderly and self-sustaining. For example, Laura brought up the example of stars last time. Okay, so a star lives, quote unquote, I'm using that in a metaphorical sense, right? A star lives for billions of years, right? And it goes through a life cycle, right? We wouldn't call it a carbon-based living organism. That would be an egregious error. But we can say, nonetheless, that it's a self-maintaining system. so what would that mean? Well, it means that, I mean, it has a kind of metabolism to it, right? It's constantly destroying parts and creating new parts, and it's a self-propagating system of plasma.
Non-biological.
Yeah, non-biological. It's self-perpetuating, self-maintaining in a way. I mean, it lasts for billions of years, a lot longer than an organism lasts for. Right? Yeah. And it stays in a fairly stable state all that time. Perhaps its identity over time consists in, right, this systemic organized behavior. So you could make that case. If it turns out that there's a science of stars, which there seems to be, it's like the astrophysicist studies the life cycle of a star. There are laws maybe covering that, right? That stars start out like this, and then they go through this phase for a few 100 million years, and then they become like that, and eventually they can become a supernova, or become a black hole, or become a neutron star, or whatever. All these different things could happen to them, depending on exactly what type of star they started out as, and how they progressed, and whether there were some weird cosmic accidents that might have occurred.
Maybe
But,
a cycle, legal cycle
yeah,
of stars.
yeah. So there could be a law-like or a law-governed cycle of these self-perpetuating or self-propagating systems of plasma. Arguably, then, they have a kind of identity based on their belonging to that kind. It's essential for a natural kind, though, that it be covered by a law or system of laws. Laws are highly general, physically necessary regularities in the natural world. Living things are an example of these law-governed systems. They're unique in that they have these master parts because they have DNA. DNA is what causes them to behave in this way, right? Because the DNA keeps on proliferating and replicating and creating bigger and bigger structures at higher and higher levels, right? And that's how you get these central nervous systems.
You can see a cyclical nature following a law.
Yes, so just like a living thing has a cyclical series of processes, metabolism, biosynthesis, excretion, absorption, and so on. Stars, I imagine, have a cyclical system as well, but though it's composed of different reactions, or whatever. But there are nuclear and physical reactions that follow a cyclical process. Only that could enable a star to sustain itself over billions of years. So through law-governed physical cyclical processes, various natural systems perhaps can gain a kind of endurance through time and be considered as autonomous, substantial or substantial-like systems in that respect. So that's, I think, relevant to the questions you've been asking me.
It's a really fascinating question. I enjoyed delving into it.
Yeah. Did you have a comment, Ryan?
I just had a question about life cycle versus alive. Which part do you need for a master part?
A master part.
A master. A master part.
I haven't seen a MasterCard lately. It's
Right.
mainly like Visa.
Right. Which part? Which would you need for a master part?
Yeah.
Do we need something that has a life cycle or something?
You do. It has to have a life cycle.
Does it
And
have to be alive?
for a master part?
Yeah.
Yeah, I think so.
But you can have, it seems like the way we've been talking about things is that we could have a life cycle without being a lot.
Yeah, you can. Well, no, it's not a life cycle. It's a physical cycle.
Non-biological.
Yeah, it's
versus
non-biological.
biological.
Right.
Yeah, it's
okay.
non-biological.
Non-biological is not really life, so it makes it a
Right.
cycle.
Yeah, it might simulate some
Right.
sort of.
Or it might be isomorphic.
Like, okay.
Yeah,
Yeah. Okay, yeah, that
yeah.
interesting.
But you don't want to confuse like stellar
Yeah.
cycles with biological processes. They have nothing to do with each other.
Right.
They may, though, exemplify some common causal pattern or something like that. But there's a big difference, right? The compositional elements are different. The one is driven by fundamental nuclear reactions, the other by biochemical reactions. They're totally
Yeah.
different kinds of structures.
Their aging is different. If we could even say the other one ages.
Oh, they do. They
It
do.
goes back to the mereology question, right?
Yeah, it's all about the parts.
Yeah.
But one of the most important forms of scientific explanation is compositional analysis, where we explain the properties of a system in terms of the laws governing the properties and relations among the parts of the system. Right? So, for example, we explain chemical reactions between compounds and elements in terms of
Their parts.
the parts, right? That electrons are exchanged between molecules, right? Or between atoms when one chemical comes in contact with another. That sort of thing, right? So we can explain like why you get salt if you mix, right, sodium and chlorine in terms of the parts that make up these two elements, like electrons. Right, so there's a whole theory about that, right?
Mm-hmm.
Like there are valences and the exchange of electrons, and they bind together to form a molecule,
Right.
and then you get salt, right?
Right.
Which
but
is
on their
totally
own.
different than like sodium or chlorine.
Yeah. Right. Yeah.
Like salt is sort of tasty and beneficial, whereas sodium and chlorine are like not
Poison.
good to eat,
Yeah.
right?
You wouldn't want to eat.
No.
No, you don't. And no, with sodium
I
either.
don't want to put it on my French fries.
Sodium's very caustic; it'll burn you. And yeah, and chlorine is like noxious. Yet together they make table salt, which is tasty and generally good, okay to eat. All those are curious things, but we try to explain them in science in terms of compositional analysis of some sort, and then laws about the parts that make up the complex things. Natural laws. Laws which say whenever you have this state of affairs, it'll be followed by this other state of affairs. And that's some kind of, first of all, a regularity, which means it always happens that way under certain specified conditions. And secondly, that it's in some sense necessary that it happen. So that's a big question. There are those who say it's in some sense necessary, but they have a lot of trouble explaining in what sense it's necessary. That if you mix these two chemicals together, you'll get salt. That it must happen that way. So the others who follow Hume say it just does always happen that way. But it's not. It's not.
Doesn't have to, it just does.
It just always does and always will, but there's no necessity involved.
Some might not come up tomorrow.
Right. So would Hume even say that it always will?
Yeah.
Oh.
Well, he would say he doesn't know that.
Right.
He doesn't know why it just does.
Yeah.
Yeah, it just does always, so far. And if it doesn't at some point, then we will have discovered it's not really a law. But if it always does, then we have more and more reason to think it's a law, though we'll never know. That was the probability increases the more times it recurs in the same way. But you can't ever reach knowledge that it will, because that would require an infinite time and awareness, which you will never have. So you can't say that it will always come up. You can say it will always come up if it's a law, right? So if it's a law, then it will in fact come up. Now whether you can know it's a law is the question. He says no, you can't. No, you can just have probability. Others have said when the probability gets high enough, you can take the leap and say, you know. And if you happen to be right, you did know. But if you happen to be wrong, then you didn't know. So,
That's fine.
yeah,
Probability.
yeah. So that's the problem of induction, which says, can we ever know that anything's a law? Scientists say, well, if it happens often enough and we never observe any exception, then we'll say it's a law. And maybe we know that, or maybe we should say we don't really know, it's just highly likely.
Well, Einstein thought the universe was a constant. For how long? A long time. So Hubble showed up.
But is there really a problem with induction, or is that just the way induction works?
Well, I mean, that's an excellent point. It is the way induction works. Is that a problem? Not necessarily, but there is the question of whether it amounts to knowledge.
Well, the kind of knowledge that we're looking for.
Well, just
Certainty.
knowledge. Certainty?
Certainty, yeah, I would say that, like,
Yeah, but that sounds like a psychological thing, like
Oh,
being, feeling really sure or
With
something.
certainty.
right, well,
I mean, if it's an epistemic thing, then it just comes back to saying it's knowledge or not. Unless by knowledge you mean absolute certainty, in which case it's definitely not that.
yeah, I don't know if any knowledge.
Yeah, right.
Well, other than like,
And maybe-
maybe a priori.
Yeah, maybe.
Yeah.
Yeah, so but this is not that kind of knowledge either. So leaving that aside then, right? The question is whether it amounts to knowledge or not. So some have said yes and some have said no. So, yeah.
I think Kant would say that universal laws are a priori and therefore are considered true.
Maybe universal laws of logic? Or do you mean also universal laws of science?
Science.
Yeah, he did say that.
Yeah, but I don't know if we would know what laws exactly. Our knowledge of those laws, like which thing is a law, that's not a priori. Our knowledge that like gravity is a law.
Well, depends on what lens you're looking through.
Kant sort of thought that like, some of the features of our scientific laws were a product of the categories.
Oh, okay.
Was he right about that? Not too many people think so anymore. Yeah, it's controversial, but it's certainly difficult to establish that. So he thought that Newton's law of gravity, or that it had the form of an inverse square law, was a product of our forms of intuition and categories, and so it would be a priori. Hey, but guess what? Einstein overthrew Newton. So, yeah, so I guess Kant wasn't right about that.
But that was based on the ability to know something at that point in time, right?
Yeah.
Once science evolved into a
Yeah,
different-
exactly. So isn't it perilous to assert that the science of today is, going to be like a priori in some
Right,
sense? No.
right.
Yes.
It's not.
No. So I think Kant was on the wrong track with that. if he's right that somehow all science is conditioned by some categories, then they're so high level that that they can't determine a
They're
specific.
not knowable.
Yeah,
We
They're n-
can't know.
no. Or we can't know that they determine a specific scientific theory, anyway. Whatever they might be. But it seems possible for the mind to evolve over time
With new information.
with new information and with new biological structures.
New drugs.
Yeah, enhancements so that our conceptual scheme could change over like millions of years to, you know.
AI could supplement.
Yes,
our mind.
right. So I don't think we can say that the way we think today is necessarily the only way that we can think. That could change over the epochs of time. And we could then come to maybe a deeper understanding of reality than we have now. And so on and so on and so on. I think it would be a mistake at any point to try to put a cap on that and say, this is the end of all evolution.
Well, they tried that in the 1800s with patents. They said everything that could be invented had been invented. And then along came the internal combustion.
Now, it's very foolish to say that we've reached the end of science or the end of history or the end of philosophy.
Heard of someone saying we've reached the end of philosophy.
Yeah.
He did what?
He said that he solved all of philosophy.
Oh, through his word game?
Yeah, well, before that, actually.
Oh, oh.
Yes, generally turns out not to be so.
Yeah, he actually goes back on himself.
Okay. Okay, so I hope that's useful. In the next lecture, I'm going to go into the other side of identity, which is diversity, and we'll look at the question of what is the principle of individuation for things, for entities of different sorts. In medieval times, this was called the Principium Individuationis, the principle that individuates or separates one object from another. Yeah, so we'll be looking at some different accounts of diversity between entities.